Okay, we have carbon dioxide and water in equilibrium with carbonic acid. Heat is represented here as a product, which means that the forward reaction releases heat. If the reaction releases heat, that means it's exothermic. If there is a system at equilibrium and the temperature is raised, what will happen? Okay, so if we are increasing heat, that will drive the reaction to the left. Equilibrium will be shifted, the reverse reaction will happen. So that means we'll get more water and more carbon dioxide. So which of these two makes more sense? Well, more carbon dioxide will form because the reverse reaction will be favored. If there's a system at equilibrium and more CO2 is added, increase the concentration of CO2, what will happen? Well, when we add more of our reactant, that drives the reaction to the right. That means the forward reaction is going to be happening more. So we'll be producing more carbonic acid, we'll be releasing more heat, and we'll be consuming water. So what will happen? More CO2 will form. No, we've already added more, so we're trying to remove that CO2, so that won't happen. More carbonic acid, H2CO3 will form. That would be correct. If there is a system at equilibrium and pressure above the liquid is increased, what will happen? Well, our product here is aqueous, it means dissolved in water. So it's not a gas, that's not going to matter. Liquid water, a reactant, not going to matter. CO2 gas, so gases and pressure are related. So if we're increasing the pressure, the concentration of our gas has increased. We want to relieve that pressure. We're going to make less gas, so we're going to shift in the direction of the forward reaction. So more concentration of our gas leads to a forward reaction. So let's look at our options. More CO2 will form. No, that won't happen. We're trying to use up CO2 gas. More carbonic acid will form. Yes, because we're going to be consuming our reactants and making more products. For this reaction, we have calcium oxide reacting with water to produce calcium hydroxide, and it releases heat. So if our reaction in the forward direction releases heat, it is an exothermic reaction. Endothermic would require heat in order for it to go. If there's a system at equilibrium and the temperature is raised, what will happen? Well, if we raise temperature, that means we're adding heat. If we're adding heat, we're stressing the system that it wants to go in the reverse reaction. We shift equilibrium left. More calcium oxide will form. That makes sense because we're going in the reverse direction. We'll be increasing the products of that, which are these two reactants here. We'll be consuming our calcium hydroxide as the reverse reaction happens. If there is a system at equilibrium and sodium chloride is added to the solution, what will happen? Well, we don't have any sodium ions and we don't have any chloride ions in the system. So nothing's going to happen. If you had sodium involved or chlorine involved, then that would add a stress to the system. If there's a system at equilibrium and pressure above the liquid is increased, what will happen? Again, we're looking for any reactant or product that is a gas, solid, liquid, solid. A pressure increase or a pressure decrease is not going to do anything.